NASA's Europa Clipper mission is set to launch in October 2024 on a SpaceX Falcon Heavy rocket. This mission aims to explore Jupiter's moon Europa and investigate whether it could harbour conditions suitable for life. Europa, discovered in 1610 by Italian astronomer Galileo, is one of the most promising places in our solar system for life beyond Earth. The moon, slightly smaller than Earth's moon, is covered with an ice shell approximately 20 kilometers thick. Beneath this icy crust lies a liquid saltwater ocean up to 150 kilometers deep, containing more than twice the amount of water in Earth's oceans. The mission's primary goal is to confirm the existence of the ocean, characterize its nature, and understand the process of surface ice-ocean exchange. The spacecraft will not orbit Europa directly, but instead orbit Jupiter, conducting 44 flybys of Europa at altitudes ranging from 25 kilometers to 2,700 kilometers over its 3.5-year mission. This strategy minimizes the spacecraft's exposure to Jupiter's intense radiation while allowing it to collect and transmit extensive data back to Earth. To achieve its objectives, the Europa Clipper is equipped with a sophisticated suite of 9 instruments designed to study Europa's interior and ocean, geology, chemistry, and habitability. These instruments include the Europa Thermal Emission Imaging System. This instrument will provide high spatial resolutions and multispectral imaging of Europa's surface in the mid to far infrared bands, helping to detect geologically active sites and areas such as potential erupting plumes of water into space. The Mapping Imaging Spectrometer for Europa, an imaging near-infrared spectrometer that will probe the surface composition of Europa, identifying and mapping the distributions of organics, salts, acid hydrates, water ice phases, and other materials. This will help scientists relate the moon's surface composition to the habitability of its ocean. Europa Imaging System, a visible spectrum imaging suite consisting of 2 cameras to map Europa's surface and study smaller areas in high resolution. Europa's ultraviolet spectrograph. This instrument will detect small plumes and provide valuable data about the composition and dynamics of the moon's exosphere. Radar for Europa assessment and sounding, ocean to near surface. A dual-frequency, ice-penetrating radar designed to characterize and sound Europa's ice crust from the near surface to the ocean, revealing the hidden structure of Europa's ice shell and potential water pockets within. Europa Clipper Magnetometer. This instrument will characterize the magnetic fields around Europa, helping to confirm the existence of the subsurface ocean and measure the water's depth and salinity. Plasma instrument for magnetic sounding. PIMS will measure the plasma surrounding Europa to characterize the magnetic fields generated by plasma currents, which will mask the magnetic induction response of Europa's subsurface ocean. Mass spectrometer for planetary exploration. Mass specs will determine the composition of Europa's surface and subsurface ocean by measuring the moon's tenuous atmosphere and any surface materials ejected into space. Surface dust analyzer. SUITA will measure the composition of small liquid particles ejected from Europa, providing the opportunity to directly sample the surface and potential plumes of low-altitude flybys. The Europa Clipper mission will also use its radio antenna to perform additional experiments and learn about Europa's gravitational field. By sending radio signals between Earth and the Moon and characterizing the Doppler shift in the return signal, scientists will be able to create a detailed characterization of the spacecraft's motion. This data will help determine how Europa flexes in relation to its distance from Jupiter, revealing information about the moon's internal structure and tidal motions. The spacecraft is designed to withstand the intense radiation from Jupiter's radiation belts. It will receive a total ionizing dose of 2.8 megarands. during the mission, protected by a radiation vault with 0.3 inches thick aluminium alloy walls that enclose the spacecraft's electronics. The electronics will also be nested in the core of the spacecraft for additional radiation protection. By exploring Europa, NASA aims to understand the moon's potential to support life and aid in the selection of a landing site for a future Europa lander mission. The mission's findings could provide critical insights into the habitability of other ocean worlds in our solar system and beyond. If you like this video, make sure to like and subscribe, and also if you want to learn more about this, I've got the sources for this video down in the description below. Thanks for watching, peace.